All right, we are going to be looking at absolute value and then looking at classifying different types of numbers. So absolute value is the distance a number is away from 0. So as you can see over here, -3 is 3 away from 0. 1, 2, 3. The absolute value sign are these straight lines around the number. That's saying that we are finding the absolute value of -3, which is +3. On the other side, absolute value of 5, we have the absolute value signs on the side of the number. 5 is 1, 2, 3, 4, 5 away from 0. So the absolute value is 5. A lot of times people want to think of it as the opposite, and they'll say, oh, it's -5 because the absolute value of -3 is +3, and I'm dealing with opposites. But that's not accurate. We're saying, what is the distance away from 0? Distance is always a positive value. So when we're finding the absolute values, the absolute value of -7 is 7. It's 7 away from 0. The absolute value of 18 is 18, not -18. It's 18 away from 0. The absolute value of -0 and 4/10 is 0 and 4/10. The absolute value of 2 and 6/10 is 2 and 6/10. We can also do them with different types of expressions. Later on in this unit, we will incorporate some more difficult expressions with absolute value, but since we haven't gotten into adding and subtracting positive and negative values, right now we're just looking at some basics. So I like to write underneath, okay, the absolute value of -7 is 7, absolute value of 12 is 12, 7 plus 12 is 19. For number 6, absolute value of 18 is 18, absolute value of -2 is 2, 18 plus 2 is 20. Absolute value signs can kind of be thought of like parentheses. They're grouping symbols, so we do them first. So first I'm going to do 28 minus 19, which is 9. So we are finding the absolute value of 9, which is 9. And then here again, kind of like parentheses. First I'm going to do within the parenthesis or within the absolute value signs, 35 plus 6 is 41. We're doing 50 minus the absolute value of 41. So 50 minus 41 is 9. Then looking at which numbers have an absolute value of 12. So there should be two values, +12 and -12. Both have the absolute value of 12. Which numbers have an absolute value of 50? +50 and -50. And what about decimal 4.2? Positive and the negative. And then just a real world example. A blue whale swims at -26.3 meters. A bald eagle flies at 17.8 meters. Find the following. The absolute value of the blue whale's distance is 26.3, right? We wouldn't say necessarily, maybe in some instances, but generally speaking, we wouldn't say, oh, a blue whale's at -26.3 meters. We'd say they're 26.3 meters below sea level. And the bald eagle, the absolute value of 17.8 is 17.8 or 17.8 above sea level. So which one is closer to sea level, or that 0 or that ground? The 17.8 is lower, it's closer to 0, so the eagle. Now we're going to look at rational numbers and classifying those. So there are different types of numbers, some more specific, kind of like with quadrilaterals, and then rectangles, and then squares. Every square is also a rectangle, which is also a quadrilateral. But not every quadrilateral is a square, or not every rectangle is a square. So it's the same type of thing where we get more and more specific, and those really specific ones are going to have multiple categories that are true for it. So specifically, We are looking at the real number system. And I'm going to highlight this in 2 colors. So the real number system is made up of numbers that can be represented on a number line, and they can be classified according to their characteristics. Specifically, they are made up of rational and irrational numbers. So there are things that we call imaginary numbers that wouldn't be in the real number system. We're not getting to that right now or this year. So every number that you are going to be given is a real number. So it's either going to be rational or irrational. It can't be both. So irrational numbers are a number that cannot be expressed as a fraction, as A over B. So non-terminating decimals that are not repeating. So they're decimals that go on and on and on forever with no repeating pattern. So a lot of times like square root values are going to be irrational, or pi, because pi goes on and on forever. A rational number is a number that can be expressed as a fraction, but specifically where b is not equal to 0. This includes positive numbers, negative numbers, whole numbers, fractions, terminating decimals, so decimals that end, and repeating decimals. Because if you think of like 0.3 repeating, that is 1/3 as a fraction. So it could be written in fraction form. The next specific of rational numbers is integers. They are all positive and negative counting numbers. The reason I say counting numbers is if I told you to count to 10, you're going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You're not going to say 1.2, 1 3/4, 2, 2.078, 2.33. You're just going to be doing those clear numbers. And a lot of times people say they're whole numbers, but whole numbers are all positive counting numbers. So integers are those counting numbers that are positive and negative, no fractions, no decimals. Whole numbers are all the positive counting numbers, including 0. So that part is important to note, including 0. Oops, I did the wrong one, including 0 here. So whole numbers do not include fractions, they do not include decimals, and they do not include negatives. And then natural numbers are basically the same as whole numbers. The only difference is it does not include 0. So same thing, no fractions, no decimals, no negatives, and not 0. Because 0 is kind of unnatural in some senses, right? If we plugged in 10 divided by 0 on the calculator, that would say that it's an error, it doesn't work. So we have here the real number system, again, split into either irrational, or rational. Natural numbers should be included on here as well, more specifically, kind of in the middle here. But these numbers, 27 over 4, that comes out to a decimal, which means it's not an integer or a whole number. But the number 3, since it's an integer, it also is a rational number. So anything on the outside it also would be, but on the inside, -3 is not a whole number because it has a negative. Versus the number 0, it's also an integer and it's also a rational number. And you can kind of see it broken down over here as well. A natural number is a whole number, which is an integer, which is a rational number, which is a real number. But a rational number doesn't necessarily mean it applies backwards. So let's look at this chart. I'm going through and asking myself, okay, so as soon as I see that it's a negative value, I know it's not a natural number, it's not a whole number. It is an integer because there's no fractions or decimals. If it is an integer, it is also a rational number. It is also a real number. 0. Remember that natural numbers do not include 0. So 0 is not a natural number. It is a whole number. If it is a whole number, because there's no decimals or fractions, it is also an integer. It is also a rational number. It is also a real number. 4. It is a natural number because there's no fractions or decimals. It's not 0. That means it's also a whole number. It's also an integer. It's also a rational number. It's also a real number. 14/5. So at first you look at it and you're like, hey, it's a fraction, so it's automatically not going to be natural or whole number, but you do want to double check things to make sure it doesn't come out to a whole number. So if you divide that, you get 2.8, which is a decimal. So what that means, it's not a natural number, it's not a whole number, it's not an integer. So it is a rational number and a real number. 24.66 has a decimal, so it can't be natural, can't be whole, can't be an integer. It's a rational number and a real number. Square root of 7. So I'm going to plug that into my calculator and then I'm going to type it out here. The square root of 7 is 2.64573 1, and so on, and it keeps going. So automatically when it's a decimal, we know it's not natural, we know it's not whole, we know it's not an integer. But since the decimal goes on and on forever, it is not rational, it is irrational. But again, both rational and irrational are real numbers. So everything that we check off here should be a real number. 1.3 repeating. So though the 3 goes on and on and on forever and doesn't terminate, it repeats. And we have said a repeating decimal is a rational number, not an irrational number. Since it has a decimal value, it can't be any of these first 3. But it's rational and real. -2/5. So it is a fraction. I would double check though to make sure it actually is a decimal value. We get 0.4 or negative. So it is a decimal value, which means not natural, not whole, not an integer. It is a rational number and a real number. -0.4 repeating. Again, it has that repeating aspect, which means that, okay, decimals are going to be no for natural, whole, and integer, but it is a rational number because it repeats. 2 and 5, 2 rad 5, 2 times the square root of 5. I'm going to plug that into my calculator. I know a lot of times that when we have square roots, it's going to be irrational, but I'm going to double check. So I get 4.4721 and so on. So it's a decimal that goes on and on forever and does not repeat. Therefore, it is irrational and a real number. Square root of 625. If you plug that into the calculator, you actually get a whole number, 25. So being careful with that, again, you see the square root, you're going to think irrational right away, but some of them simplify to whole numbers. So 25 is natural, which means it's whole and an integer and a rational number and an irrational number. Nope, sorry, and a real number. And then last one, 22/11, same thing as the square roots. Right away, we see the fraction and we think that it's just rational, but 22 divided by 11 gives you the whole number of 2. So it's natural, which means it's whole, which means it's an integer, a rational number, and a real number. And that is it.